Dear students and civil engineering faculty members, today we are going to see a simple derivation on how to calculate the horizontal reaction in a two-pin arch. So in two-pin parabolic arch, as you observe from this figure, you can see that RC is the horizontal reaction, which is equal to RD, and RE and RB are the vertical reactions. You can apply a load W at any distance LA from the left support, and the span of the arch is L. So with this details, we will go further and evaluate the value of the horizontal reaction RC and RD. I will be employing the strain energy method to derive the expression for the horizontal reaction. So here we go. So this is the experimental setup, and this experimental setup is idealized like parabolic arch having vertical reactions and horizontal reactions, and the load is applied at a distance LA from the left support. The point here is you have the expression for bending moment up to span LA, that is equal to RA times x, and when the x crosses the value of LA, we will have another expression for bending moment. So there are two expressions for bending moment where the limitations of x is from 0 to LA and LA to L. And here we know that the expression is RC is equal to RD is equal to 5W LA by 8H L cube into L cube plus LA cube minus 2L LA square. So how to derive this horizontal reactions, that we will see today, and how we can use the strain energy methodology. Yeah, proceeding further, the arch has been idealized by this diagram where you find that the load W is applied at a distance LA from the left support, and here at the center you can see the crown has a rise of H, and the span of the arch is 0.5 meters. Now, how to derive this reaction? So I have already provided you the details about the reactions RA, RB, RC and RD. Now the first thing is to calculate the vertical reactions RE and RB. So here we go, and before that we can see that at any distance x, we can see that the value of the rise of the arch is 4 multiplied by H into x into L minus x by L square, where H is the rise at the center of the parabolic arch. So using this formula, we can evaluate the rise at any distance x from the left support. So using this y, we are also going to estimate the horizontal reactions. Let's see how to do that. So the very first step is to evaluate the reactions RE and RB. So for this, first you use the equilibrium equation, summation of MB is equal to 0, and using this you can find out that RA is equal to W into L minus LA divided by M. Now proceeding further, you employ the second equilibrium equation, summation of V equal to 0. Then using this you will get the RB equal to W times LA by M. Yeah. Proceeding further, so this is the real strain energy expression for estimating the value of horizontal reaction H is equal to M into Y dx by EI divided by y square dx by EI. Let me assume that the EI is constant, flexural rigidity is constant, the value of Young's modulus is constant, the value of moment of inertia is constant, and flexural rigidity EI is also constant. So we can rewrite the formula in this way. Now note down the formula that H is equal to 0 to LA M1y into dx plus LA to L M2y dx divided by y square dx 0 to L. So in this problem, we can observe that we have got two expressions for the bending moment. As I told you earlier, the first case is for x less than LA, and the second case is for x greater than LA. So we have to evaluate the numerator two times, that is, we have to do the calculation for the first expression and second expression, and then add the both for getting the total value of the numerator and divide it by y square dx. Yeah, here we go. So let's find out the denominator first. We know that denominator is 0 to L y square dx, and we already have y equal to 4hx into L minus x by L square. So you square it, you get this value, then you apply the integration. So on working out the integration, finally we end up with y square dx is equal to 8h square L by 15. So this is the expression for the denominator. Yeah, then we go for evaluating the numerator. As I told you, we have two expressions where the limits of x are between 0 to LA, and the second limit is between LA to L. Yeah, then we evaluate the first expression, that is m1 into y dx. So here you can see that this x is less than the LA, where LA is the point of application of the load W. Now proceeding further, you multiply this m1 by y dx. So here you can see that m1 is nothing but RA times x. Then you multiply it with the expression for y. You substitute the value of RA. Then after evaluating everything, finally you get 4wh by L cube into L minus LA multiplied by LA cube by 3 minus LA power 4 by 4. So this is the expression for the first term of the numerator. Then we move on to the second term. Here you can notice that the x has crossed LA, and so the limits are between LA to L. So the expression is m2y dx. Yeah, we will calculate m2. So at this location x, you know that the value of m2 is RA times x minus w into x minus LA. That's what written here. Then you substitute the value of RA. After simplification, finally we end up with m2 is equal to WLA by L into L minus x. So moving out further, we evaluate the expression for m2y dx where the limits are between LA to L. Yeah, you substitute all the values and work out the simplifications. Finally, you get this long expression, and after simplification, you will find out that m2y dx is equal to 4wlah by L cube into L power 4 by 12 minus LA power 4 by 4 plus 2L LA cube by 3 minus L square LA square by 2. So this is the second term of the numerator. Now we will add the numerator 1 and numerator 2. Adding all these things, finally we have 4wh by L cube into LA power 4L by 12 minus LA cube L square by 6 plus L power 4 LA by 12. Yeah. Proceeding further, here we want to calculate the horizontal reaction. So numerator divided by the denominator. So we have the expression for numerator and also the denominator. So you can see that after simplification, finally we end up with RC is equal to RD, that is equal to the horizontal reaction, which is nothing but 5WLA by 8HL cube into L cube plus LA cube minus 2L LA square. So this is how we derive the expression for horizontal reaction in two-pinned arches. Thanks a lot for watching. If you have any queries or doubts, please mention in the comment section. Don't forget to subscribe the channel. Thank you.